All right, Algebra 2, here is your first video for the exam review, and this is quadratic functions and their algebra. I do want to show you a lot of different calculator tricks as we go along, so I know some of this will look like it might be new things. It's just because these are some of the little tricks that I've done. Understand that all your old methods for solving and factoring and doing all those kind of things, those are all going to be just fine for you to use as you go forward as well. But I am going to show you a lot of tricks. Your calculator will help you immensely on this exam. I really think you might be able to do everything if you needed to, just using your calculator. So these first few problems all say to factor the following completely. There are no equal signs. We're not solving these. We just need to factor them out. So as I start and I look at question number 1, I should always ask myself first, is there a GCF between 2x cubed, negative 20x squared, and 78x? And there is a GCF of 2x. So if I factor out the GCF of 2x, I'll be left with 1x squared, negative 10x, and negative 39. And now I need to look at the trinomial that's in parentheses and try to factor that as well. So here is the little trick that I use with my calculator. I go to y equals. I'll do a times c, so 1 times negative 39 is negative 39. And I divide by x. What this is going to do when I look at the table, so if I hit second graph and I look at the table, this shows me that all the pairings of numbers that I would have to multiply together to get 39. So you can see 1 times negative 39 would give you negative 39. 2 times negative 19.5. So that wouldn't be one of them that I would count. And if you were to make this list, you would see 3 and negative 13. 4 and negative 7.5. It's not a whole number, so that's not one of them that we would ever put in our list. I'm just looking for the whole number pairs that go together. So I can see 1 and negative 39. I see 3 and negative 13, and the rest are decimals. And I can scroll up and down if I need to. But I'm going to go back to y equals, because actually what I want to do is I want to take that x value. So I want to go down to y2. I want to take the x value. I'm going to add that first y value to it. So when I found the value in y1, I want to add it to it. So I'm going to take x plus, and then y1, if you hit alpha trace, y1 is your first selection. So now when I look at my table, I'll have 2 columns. I'll have a y1 and a y2 column. And you'll see in black are my x values again, and in blue are the y values. And then in y2, you see what happens if I add the x and the y together. So as I look at 1 plus negative 39, I see negative 38. And I see 3 plus negative 13, I see negative 10. That's exactly what I want. I'm looking for the one in red where there's a negative 10. So as I look at that negative 10, you'll see negative 10 right there. That negative 10 tells me that the 2 values that I'll use are positive 3 and negative 13. So when I want to factor that, I have 2x. The airplane method, if you remember the airplane method, that's 1x squared, so I'll put 1x up front. And we said that we were using positive 3 and negative 13. So positive 3 and negative 13. And that is completely factored. As I go to question 2, the first thing I ask myself, look for a GCF. I do not see one. So I'll do a times c is the key. 9 times 5 is 45. And again, if you remember, by hand, we used to write down all the factors of 45. I can do this right in my calculator. So y equals, this is positive 45, so 0, 4, 5. I still divide by x. That doesn't change. I'm still going to do my x plus my y1. So let's look at the table. So second graph. I'm looking for the pair that add up to 18. So I'm looking in y2 for positive 18, and I see it. I see positive 18 right there. So my two factors are going to be positive 3 and positive 15. So I want to use positive 3 and positive 15. Those are going to be the two numbers that multiply to give me 45. Those will be the ones that multiply to give me a 45 and add to give me 18. So I can use 9x squared. The airplane method tells me 9x goes in the front of both parentheses. And then I have a positive 3 and a positive 15. In airplane method, make sure that you check for dividability within each one of the parentheses. So I have a 9x and a 3. Both are divisible by 3. So that parentheses reduces to 3x plus 1. And 9x and 15 are both divisible by 3. That reduces to 3x plus 5. So that final answer, 3x plus 1 and 3x plus 5. As we move forward, I'm going to do the same stuff. Number 3, 20x squared minus 33x minus 36. I look for a GCF. I don't have one. So I'm going to do A times C is the key. 20 times negative 36 is negative 720. So negative 720. So y equals negative 720 divided by x. And then my second one is still going to be x plus y1. I'm looking for negative 33. So let's look at the table. I need negative 33. As I look at my pairs, I see negative 719, negative 385. Looks like I need to scroll down more. And let's go down till we get to negative 33. There it is. So negative 33 looks like it uses positive 15 and negative 48. So 15 and negative 48. 15 and negative 48. Just makes my life a lot easier. Airplane method tells me 20x will be in the front of both. One will get a positive 15, one will get a negative 48, and then check to see if they simplify. So the first parentheses, it looks like both simplify by a 5. So if I divide by 5, I'll get 4x plus 3. And this side, it looks like they're both divisible by 4. I divide them both by 4. 20x divided by 4 is 5x minus 12. And that is your factorization. Number 4, 10x squared minus 7x minus 12. Look for a GCF. There's not one, so A times C. 10 times negative 12 is negative 120. And I'm looking for negative 7 in the middle. So here we go. Y equals negative 120 divided by x. And then y2 will have x plus y1. And we said I'm looking for negative 7 in the middle. So as I look here in my screen, I see a positive 7. I need negative 7. So there it is. 8 and negative 15. So 8 and negative 15 will be the two numbers that I use. Airplane method stays the same. It's 10x squared, so I'll start with 10x. I have a positive 8 and a negative 15, and then check for simplification. This side, 10 and 8 are divisible by 2. So that would be 5x plus 4. And the right one looks like it's divisible by 5. So 2x minus 3. And that would be completely factored. Number 5. Number 5 is a two-term So I'm thinking either difference of squares or sum and difference of cubes. And this happens to be two perfect squares. So two perfect squares, factors, real easy. Square root of the first term, so the square root of 16x squared is 4x. So I'll do 4x in the front of both. And the back is the square root of 81, which is 9, goes in the back of both. One gets a plus, one gets a minus. And that is factored. Number 6. Number 6, I can just tell looking at this, 128 x squared y and 18y cubed. There is a GCF in here. And they're both divisible by 2 because they're even. They both have a y in there, so I can take out a 2y at least. So if I were to do that, 128, that would be 64x squared is left over. And then minus 9y squared will be left over. And then always look in your parentheses to see if it'll factor. This is two terms. They're both perfect squares. So just like number 5, 64x squared would be 8x. And the square root of 9y squared would be 3y. One gets a plus, the other gets a minus. That is completely factored for number 6. We're going to look at number 7. It says, what is the domain and range of this function? Domain and range when a picture is given. It's as simple as figuring out domain, I think left and right. How far left will it go? How far right will it go? Range, I think about up and down. How high will it go and how low will it go? So let's start with the domain. How far left will this graph go? As I see it going over, I see it at -1 and it's going down really fast, but it's also moving to the left, and eventually it'll come all the way out here to -infinity. It'll take a while to get there, but it'll get there. To the right, same thing. It's going down really, really fast, and it's going over slowly, but it is going over, and there's no reason that it wouldn't continue on to positive infinity. So the domain is -infinity to infinity. Also what we call all real numbers. And this is the same thing as saying all real numbers. The range is how high will this thing go? I can see the top of this graph is right here. That's as high as it's going to go. That's up 1, 2, that's up 3. Now how low will it go? The arrows show you that it's going all the way down here to -infinity. So when I think about what is happening, this thing is coming from -infinity, and it's going all the way up to 3. And it is allowed to equal 3, so you can put a bracket on that 3. Another way to write this is in terms of y. Y has to be any number that is smaller than or equal to 3. And two different ways to write the same answer. Number 8. Determine the value of c that makes x squared minus 6x plus c a perfect square trinomial. This is part of the process of completing the square. So as I go x squared minus 6x plus, this is how we showed it in class. What is in the box? Well, in the box, we remember take half of b. So in this case, half of -6. Which is -3, and then square that number. So -3 squared is 9. So c needs to be 9. Half of the middle term squared. Number 9 says write the quadratic equation in vertex form by completing the square. Identify the turning point of the function. So if I want to complete the square, first step is clear the constant. So I have y. I'll subtract 12 on both sides. So y minus 12 is equal to x squared minus 6x. And now I want to create that perfect square trinomial, what we just talked about. So what do you want to add to both sides? I'm going to add some box out here to both sides. Well, half of negative 6 is negative 3. So this right side is going to be x minus 3 quantity squared. And then 3 squared is 9. 9 is what's getting added to both sides. So I have to add 9. So my left side is 9 and y and negative 12, which is the same. If I combine like terms, 9 minus 12 is negative 3, so y minus 3. And vertex form, we want to make sure we have y equals, so add 3 to both sides. So y equals x minus 3 quantity squared and plus 3. So my vertex, or the turning point, are the coordinates. It says x minus 3. Remember, the parentheses make you believe lies. The parentheses are absolutely lying to you. So make sure that you plug in a positive 3 here instead of the minus 3. And then the y-coordinate is the number on the outside, and it is not lying to you. So a 3. Now we talked a lot about how can the calculator help you. Well, one of the things that I can do, I'll bring up the calculator. I'll go to y equals. And I'm going to put in x squared minus 6x plus 12. And this one's not really as much of being able to complete the square. Calculator is not going to do that. But what I'm going to do is I'm just going to check myself. I want to put in x minus 3 quantity squared and then add 3. And I'm going to hit graph or zoom 6 if I want a pretty graph. And I'm just going to make sure those two graphs lay right on top of one another. And you saw the blue one come in and the red one lays on top of it. That tells me that those two graphs are the same. If you have to identify that turning point, you can hit second, trace, and you want to calculate the bottom, which is a minimum, so number 3. So I go down to number 3. The calculator asks for a left bound, so that's to the left of the bottom. And then right bound, I'll take this over to the other side. Oh boy, got a little crazy here. I apologize. I'll wait on the calculator. There we go. And then the guess somewhere in the middle. And there it shows us that x equals just about 3, and the y value should also be about 3. Final problem is problem number 10. It says Jason jumped off a cliff into the ocean in Acapulco while vacationing with some friends. His height as a function of time could be modeled by the function h of t, where t is time in seconds and h is height in feet. Question wants to know how long did it take Jason to reach his maximum height, and it even tells us what to use. So I just need to know what is A, what is B, what is C. Those things never change. A is equal to negative 16. B is equal to positive 16. C is equal to 480. So how long did it take? X equals the opposite of B. The opposite of 16 is negative 16. All over 2 times A. This is 2 times negative 16, which is negative 32. Negative 16 divided by negative 32 is 1/2. So how long did it take? It takes 1/2 of a second. What is the highest point that is reached? Now, if it reaches its maximum height after 1/2 a second, then I just take my equation, negative 16, 1/2 squared, plus 16 times 1/2 plus 480, and I evaluate. This is negative 16 times 1/4 plus 8. Half of 16 is 8 plus 480. A fourth of negative 16 is negative 4 plus 8 plus 480 is 484 feet. And the last one says, Jason hit the water after how many seconds? So the best thing to do, jump into your calculator. Y equals, we'll put in negative 16 x squared plus 16x plus 480. And take a look at the graph. He hits the water right over here. And when we take a look at the rightmost zero, I can calculate it. Second, calculate the zero, left bound, and right bound. And guess. And it shows us the zero is at 6 seconds. That is it for the first section of the review.